Hello, my name is Ron Frizard, and this is the first part of a 5-part series on how to pack a pump with mechanical packing. This series is going to cover all the facets of installation of pump packing. We're going to break them down into small, manageable steps. First one we're going to cover is common failure modes of pump packing. After that, we're going to talk about how to measure and inspect the stuffing box that we're actually going to put the packing into. Next, we're going to talk about lantern ring basics, how the lantern ring works and issues like that. Next, we're going to talk about how to stick packing into the box and how to make sure it goes in correctly. Last, we're going to talk about starting up the pump. The best chance to understand how well the pump packing is working and diagnose a problem is to look at the rings as they come out of the stuffing box. So as you are removing the packing from the stuffing box using packing pullers and trying not to score or damage the shaft, keep them in a bag and label them, if possible, where they're located into the pump. If the rings are hard to get out, you could also use a degreasing solvent to help loosen the packing. Once you have the packing out of the box, you can now look for common packing failure modes. The number one issue that we see for premature packing failure is solid embedment into the ID of the packing ring. These solids stop the packing from forming a tight seal on the rotating shaft, creating uncontrollable leakage. Solid embedment is caused because of a poor flush system. Could be such things as poor flush pressure, poor flush quality, meaning solids trapped into the flush water, or lantern ring dislocation. We will discuss this in more detail in the third video of this series. The second issue to look for while reviewing the rings is glazing, which is really burning of the PTFE that's inside of packing rings. PTFE is a polymer that has a high thermal growth rate and a transition temperature at about 500 degrees F. That takes something from soft to very hard. This can be done very easily when you over-tighten PTFE, where the heat from the shaft can actually cause the packing to grow and create like a runaway train situation where we can get up to the 260 C or 500 degrees F temperature limit. Signs of glazing are rings that come out of the stuffing box hard and stiff. Also, there's a distinct smell of burnt plastic. Also, you might see shaft wear or actually shaft damage. The best remedy to solve this problem is to change the fiber to either a carbon graphite that can't glaze or a glaze-resistant fiber like Nomex. The third most common failure mode is the wrong packing was selected for that application. This could be either the wrong size packing or one that can't handle the parameters of that equipment. For example, the temperature range, the pH range, or the speed range. We'll talk more about the sizing issue in the next video, but let's talk about if it was out of range by such things as chemical attack. If that's the case, it leaves the packing brittle and mushy. If it's over its temperature range and shaft speed, it will really show signs of fiber fracturing and burning. And if any of these are seen, you really should review the technical limits of the packing selected with all the chemicals and that the packing will come into contact with, including cleaning materials. Hey, the last issue to look for is related to the pump clearances. Packing is trying to create a tight seal in the stuffing box, and excessive clearances can lower the sealing load, resulting in leakage and constant adjustments. The telltale sign is extrusion of the packing rings. The remedy is to look at tightening up the clearances of the pump. This could include new bearings or a new gland if needed. Use an anti-extrusion ring at the bottom of the box or at the top of the box that has a stronger yarn could also help. Well, this is the end of the first video. Hope you enjoyed it. Please feel free to get a hold of me and our team. Thank you.